We will discuss different factors which affect thermogravimetric curve, mean thermogram. Among these factors, one of most important factor is furnace heating rate. Mean we can heat our furnace, which is our heating element in thermogravimetry, at different heating rate. This heating rate may be 2 or 2.5 centigrade per minute, 5 centigrade per minute, 10 centigrade per minute, even 1 centigrade per minute. Mean we can apply different heating rate for our sample. If heating rate is fast, definitely final temperature will be achieved earlier. And if heating rate is slow, then final temperature required, it will be achieved later on. It took time. But what will be the effect of this heating rate on our results, on our thermogram? Let's take example of calcium oxalate. Calcium oxalate thermally decompose in 3 steps. In first step, calcium oxalate decomposed into calcium oxalate dehydrated, mean water molecule is removed. In second step, carbon monoxide is removed and calcium carbonate is formed. And then in final step, here carbon dioxide, it is removed, CO2, and remaining calcium oxide, it is formed. Now we study this calcium oxalate decomposition at variable heating rate. We are applying these 3 heating rates, 2.5, 5 and 10 degrees centigrade per minute. What will be the result on thermogram? This black line, it shows heating of calcium oxalate at 2.5 centigrade per minute, mean at slow heating rate. Now when heating rate is increased, second heating rate is 5 centigrade per minute, the effect is observed by this blue line. Now same step, we start at this temperature, mean in the presence of 2.5 centigrade per minute heating rate. First decomposition start at this temperature, say it is C01. Then same decomposition at fast heating rate. It will start at higher temperature. Mean this heating shifted toward higher temperature. Mean same sample decompose at slightly higher temperature. Similarly, when heating rate is further fast, then same decompositional step, it is shifted toward further higher temperature. So this is one major effect which is shown in this thermogram, that by heating, increasing heating rate, our thermogram curve is slightly shift toward right, mean its temperature, decomposition temperature increase. Now why this happen? When we increase our sample at fast heating rate, quickly sample is heated. Now sample is present in the crucible, say it is crucible, and in this crucible, this sample is present. It's our sample. When sample is heated slowly, like 2.5 centigrade per minute, then slowly heat is transferred to the inner part of the sample and whole sample decompose in a uniform way, because slowly heating is transferred to the all inner parts, and all inner parts also feel the same heat because sample is slowly heated up. But when heating rate is increased, say 5 centigrade per 10 centigrade per minute, then due to sudden change in heating of the sample, outer part will feel the heat, but heat is not properly transferred to the inner part and next temperature is achieved. So same step which start at C1 centigrade temperature, it will not start at C1, it is shifted to C2, means slightly higher temperature. Water evaporation starts. It starts at this temperature, but it continues to higher temperature because till whole water vapor it is not evaporated, this curve will not complete. So complete water evaporation, it shifted toward higher temperature because at fast heating rate, transfer of heating to the inner side, it become slower. Sample will shift heat toward inside, outer side quickly achieve that temperature. Inner side, it is still same, so it still contain water, so slowly water molecule will come out. Similarly at 10 degrees centigrade, again outer side will achieve that temperature and start losing water molecule. but this in second step say carbon monoxide, and carbon monoxide is quickly escaped from outer part, but from inner part it took time. So finally this curve it is shifted toward right. So overall effect of furnace heating rate which is observed in case of calcium oxalate is effect on its x-axis. Means its temperature it is shifted towards slightly high degree. And when we see y-axis percent weight loss, it is observed that percent weight loss it remain unaffected. Mean if percent weight loss, this is percent weight loss. In first case, say for example, it is some value, say it is 28% or 20%, it will remain also same for the second step and also remain for the third heating rate. Mean y-axis is not affected because y-axis will affect if this curve shifts slightly below or slightly above, but y-axis is not affected by heating rate change. If we change heating rate of the furnace, y-axis percent weight loss it is not affected. Percent weight loss it remains the same. Mean sample are decomposed in the same manner, same components they are evolved. So y-axis percent weight loss it remains the same. But sometimes it happens that due to fast heating rate, some intermediate steps they are missed. Okay? There are some intermediate steps in different reactions which occur at very close temperature. I mean there is very small temperature difference in those intermediate steps. When we use a heating rate, high heating rate of the furnace, those intermediate steps are missed. And one of most important example of that intermediate step, it's in decomposition of copper sulfate. In copper sulfate, it's copper sulfate pentahydrate. In its decomposition, first step is decomposition of water molecule. Water of coordination, 4 water molecules they are removed in first step. If heating rate is slow, then first 2 water molecules are removed, then other 2 are removed. This is first step of copper sulfate decomposition. These are 2 water molecules and these are other 2. Overall 4 water molecules they are removed. Then is next step. So after first step, here we have copper sulfate monohydrate. Then second water molecule it is removed. Now if heating rate is fast, this was slow heating rate. It was 2.5 or 2 degrees centigrade per minute. If heating rate is made 10 degrees centigrade per minute, heating rate is increased, then same copper sulfate, its curve, it appear like this. We got a single step like this. I mean 4 water molecule, they removed in single step. This intermediate step, this slight change in curve, it will disappear if heating rate is increased. If we increase heating rate, so copper sulfate, this intermediate step of 2 water molecule in each step, it combine and give 4 water molecule. This is one example. Similarly, there may be some other intermediate steps which have close temperature at fast heating rate. These intermediate steps will disappear. So this is effect of furnace heating rate on our thermogravimetric curve.